All right, today we are going to talk about geometric nets. For most of you, this should be a newer concept. So I want to really take a three-pronged approach to what we're going to do today. First thing is, in our video today, I want to define this. In doing so, I'm going to define it with an illustration. So I'll kind of do that next. I want you to be able to see how we can use a geometric net to gain a better understanding of a three-dimensional object. The second thing I want to do is with our geometrical net is I want to talk about surface area. So we've talked about perimeter, we've talked about area, we've talked about volume, and this is kind of a newer look to where we're going to apply the concept of area to a three-dimensional object. So I'll show you that as well in this video lesson. And then the third thing we're going to do is we're just going to take a look at what happens when we are missing some information. And then this is really where we're going to be doing some applying some concepts from the past. So that's my goal for us today. Is I'm going to define a geometric net. I'm going to talk to us how do we calculate surface area, and then I'm going to propose a few scenarios where what happens when some of the information is missing. So let's get started. We'll move on over and give us a fresh page here, and we'll talk about what is that geometric net. First thing I want to do is let me give you just something very basic. Is if I were to start with this, I know we say, oh, there's my square. But then what if this becomes a three-dimensional object? And all of a sudden, my square becomes a cube. Now, this is where we've been. We've talked about the different ways we can measure this, that we can look at the side lengths and we can go length times width times height. We can calculate volume. But what I want to do is what if I were to take this and to really just unfold it. Imagine if this were a cardboard box and I were to cut each side in a way that it just kind of fell apart. So can you imagine if it went and then all of a sudden, oops, hold on just a second. What if I took it and I'm going to cut it in a way that, now this is not to scale. I need to be very clear with you because space is not going to allow me to do that. But all of a sudden, if I cut it and the box just kind of fell apart. Now what I would know I would have is, right, I'm going to have, can you imagine that's the bottom of that? That is the bottom as in that right there, okay? That's the bottom piece, what is setting on the ground where I physically don't see it. I see these two sides of it, but I don't see it, okay? It would be more back in here, okay? That's that piece right there. There it is. Then each side, you have one, two visible sides, and you have a third and a fourth side back here. Those, gravity would cause them to just fall down, right? And all of a sudden, they would fall down, and there's a side, there's a side, got another side over here, and we've got a side right there. So I've accounted for all that, but I'm still not accounting for one thing, have I? The top. Where is in my net? And so just so we know, so we're clear on our language here, this here is a 3D representation of a figure, okay? This is called the net, okay? When I talk about geometric nets, it's where I'm taking a three-dimensional object and I'm laying it out on a two-dimensional surface, okay? But I'm still not there yet, right? Because even here, I've got bottom, I've got side 1, side 2, side 3, side 4. What am I missing? I'm missing the top. Well, the top has to be connected, and this is where there's no right or wrong way. It can be connected to any one of those sides, right? Because as it folded up, it could be. And I'm going to move this. I think I'm going to run out of space. I'll go down with it. So then I could say, well, here is my top. I know my line got a little squiggly, but again, I told you not to scale. Um, but then this would have been my top. That's what a net is. A net is taking a three-dimensional object and then we break it apart. So let's do this. So that's a net, and we see really there where a cube, we unfold it. Imagine it being a cardboard box, and we unfold it in a way that it allows it to become on a two-dimensional surface. We can represent a three-dimensional object. Let's take a look at. I'm gonna get rid of all this, and let's do it differently. Let's take a look this time at, what about this? Let's see here. I want you to kind of start visualizing. I'm going to show you the net first this time. Okay? I want you to see the net. And again, I cannot stress that in these, I am not doing these to scale. I'm trying the best I can, but if you were to get out some type of measuring tool, I'm sure you could realize that my artistic skills limit that. So here's my net. Again, this time, this is the net. The net is when we take a three-dimensional object and we lay it out in a manner that's on a two-dimensional surface. So now I want to ask myself, what would that look like on a three-dimensional perspective, if we turn it into a three-dimensional? So take a second, just kind of look at it and kind of, I mean, obviously we've got to do something with these triangles. Imagine these triangles folding up, right? So that triangle is going to be the end. Would you agree with me? So, that triangle, it's too long. I can do this as best I can, even to keep it scale, right? That triangle is going to set up. Oh, I don't like that. I did the same thing, but we'll live with it this time. So you see how that, it was two. I'm comfortable with that. You see how that was too wide there? Now count here. 1, 2, 3. There's 5 of them. I know that there's these sides here that see that side, and I know that this guy here, once again, is going to come up, right? Would that not be an accurate representation? Now again, there are things I have to know when I see these 3D. I know there's a side back there I can't see. I know there's a bottom there, and then there's definitely a side here. So you have side 1 and side 2. You have side, or I'm sorry, we'll call this bottom. Oop. Then we've got the bottom here. And then even back here, we've got the back of it, right? So we see how all of them are accounted for. This here would have folded up to become side 1. This is the bottom. Really, this is side 2, side 3, side 4. But I've turned my net into a geometric figure, in three-dimensional, so that we're able to look at these, and you have to, and again, man, what an excellent conceptual way to just, you have to look at the net, or look at the three-dimensional object and be able to deconstruct it or construct it. To me, this is fascinating geometry. I was telling my wife when we were discussing this how, I wish I could teach more geometry. I mean, I love more hands-on and how we're seeing it. Literally, in this case, we're seeing objects unfold. But so this is part one. Is That's what a geometric net is. So now let's talk about a little bit of application here. For the first time, I'm going to throw a word at you that's a little new to us. We're going to talk about surface area. Okay. Now let's talk here. We've got something we know. We know area, right? Area is length times width. Know that. So when we talk about surface area of a three-dimensional object, what we're going to talk about there is of each side, what's the area of it? Now, again, this is different than volume because volume, we're talking about the capacity within the object. On this, we're talking about how much area, got to stick to your guns there, length times width of each side. So um, within a normal area problem, what you're used to is, let me zoom in. I'm going to get rid of that. Surface area. You're used to this, okay? I've got this shape, and I'll go basic because I'm not trying to mathematically stump your brains this fine day. But on this, let's hypothetically, this were 4, this were 4. You know that the area is length times width, 4 times 4, 16. You can even count these blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You know that. You know that's why that is the area, okay? But what happens when all of a sudden I'm going to ask you the question, well, tell me the surface area of this figure. And all of a sudden this becomes brand new. Well, when you've seen these figures in the past, the question you've been asked is what's the volume? Length times width times height. But now I'm asking a different question. I'm dialing it back and I'm saying, hey, let's talk surface area. I'm wanting to know the surface area of this. Well, this is a different, this is a different approach because um, it's a multi-step problem. Now, clearly, you need some things defined for you, and you're going to be given that information. So all of a sudden now you're going to come in and say, well, I know this is 4. Just to make things interesting, I'm going to say this is 3 and this is 4. Again, I'm not even attaching a unit. It's just 4 units, 3 units, 4 units. Now this is where having a net becomes important, because to solve this, I can take and say, well, what would this net look like? Because if I'm talking about the different areas, I need to really unfold this on a two-dimensional. Because when we talk about area, area is a two-dimensional measurement. That's important to just really get in there, right? It's two-dimensional. What are the two dimensions? Length and width. That's why volume is three-dimensional, length, width, height. So I can take and, again, not to scale. I can't stress upon you that, okay? Not to scale here. But what I know is roughly, hope this works out, my net of this is going to look like this. And this is the work I would expect you on your paper to be showing. Okay? We've seen the cube already. All right? We've seen the cube already, that net. And so I draw my net out. And I got to get that other side. Remember, it's going to make me look like kind of a cross, because I've got all, count your sides. With the cube, think about a Rubik's Cube. You've got 6 sides. You've got 4 sides that kind of go around it, and then a top and a bottom. But now we've got something else we can kind of actually integrate into this now. And this is where you have to kind of think logistically. You know that bottom, okay? So now start with the bottom. You know this bottom is 4, and then this is 3. Right? You see that? That's 4 and 3 on that bottom. And then I know the height, so each of these sides are 4. Okay? So what I'm doing, I need to kind of think through. This is where length times width. Well, I know the bottom is 12. You see it? 3 times 4. This side is 3 times 4. And so then you have to kind of start, if each of these sides, they're all congruent, 4, 4. These are all 3s, right? That's a 4. How tall is it? Go back to that. Is it a 4? The height is 4. See it? That's your height. So when you think about each of these sides, that's how tall it is. And so you're going to have different, these are 12. The height is 4, 16, 16. And then really the top and the bottom should be the same here, 12, because that's going to have a 3. And so you can start looking at now that net that gets kind of messy, doesn't it? You see all, but that's how you're breaking it down. And you're saying, hey, I'm calculating the surface area of each one of those. Obviously, I didn't label those properly. It's 12 units squared and 16 units squared. But what you can do now the net shows me how I broke it down and did the two-dimensional surface. What if another way to do it, and some of you, and I know my mental mathematicians, you're going to look at this and maybe take a different approach to it, but you can unfold it, and then just you want to be very making sure that these sides, are matching up where they go over here, okay? And you want to make sure that that is proper when you do the net and you're calculating the surface area. But another way that you can do it, okay, is that you can go, okay, here's what I know. You got to have a few truths here in your project problem. I know that the top and bottom are the same in this problem, okay? So I could work it out and say, well, TB, that's my top and bottom. I know it's 4 times 3 times 2 because there's a top and a bottom. Do you agree with me? 1, 2. That's what I did. Length times width, and then I multiplied it by 2 to take care of the top and the bottom. Expression is 24 units square. I know that takes care of my top and my bottom. Now my sides, now be careful here. Not all sides are the same in this problem, okay? I know side 1, and then the side back here I don't see are the same. And then I know side 2 and the side over here I don't see are the same. You see that? Because they're both 4 high, but one is 4 wide and one is 3 wide. So in step 1, I've worked it out and said, here's the top and bottom. Step 2, I'm going to talk about side 1 and its counterpart. Okay, so I know there are 2 sides. Side 1 is a 4 by 4 by 2. 16 times 2, 32 units squared. Okay? And then my third step, and I know I'm running out of room. I'm back away a little bit. My third step is I'm going to look at that side 2. And again, I know there are 2 because there's this one and then the one I don't see. But it's 3 by 4. So 3 by 4. Again, there are 2. 12 times 2, then there are 24 units square. And then at the end, add them all up. So then 24 and 24, I know are 48, right? And then I'm going to add 32 to it, which will give me 80 units squared of total surface area. When you come back and, check your math with my net here, and I'll do the easy. I know there are 4 12s. 1, 2, 3, 4. 4 12s are 48. 2 16s are 32. 48 and 32. We end up with the same math. So again, different. I think you can conceptually look at it and kind of walk through it, this way. And then the net is really where you show your work. And so then that's where I'm just going to push on you. Show your understanding, show your understanding, show your understanding. The net shows your understanding. If you choose this method, you better be able to label it so that you are communicating that you understand the geographic, wrong subject, the geometric part of what you're doing. You want to be able to say, hey, I understand that there is a side and an opposite side that corresponds to it. The problem is in a short answer scenario or in an open response scenario, the most effective way, my young friends, is this. Otherwise, we wouldn't teach nets. This net fully shows that I get how that three-dimensional object falls apart. And again, this and it's just so I can refer to them. We're going to call this the net because it is a net, and we're going to call this the math. Okay, this goes back to a net is a picture. Pictures talk more than math at times. Now, within the net, there is math, and within the net, you could pair that together. But what a wonderful way to really show your understanding. The surface area is how many of those little squares does it take just to cover the outside? It would take 80 of those. If those were inches, 80 1-inch tiles. We're not talking about filling it, we're talking about the outside. The net is a wonderful way to show that. You'll get plenty of practice with this module on that. I do want to show you one last thing, and I know we're running long, but at this point you should be used to that with me. Is let's talk about a shape like this. And I'm going to keep it simple because of I'm running long on time, and you are probably at the point where you're very bored with me, which I get it. So I've got this shape, and I want to know. I want to know surface area. I'm asking for the surface area, but what happens when um, you're given, and just I want to keep it the same. Watch this. Just because, again, I'm rushing on time here. So I've got this. What if you weren't given? You were given the 4, x, and 3. And then you were told this equals 80 units square. So now we've got a situation where you might be in a situation to find a missing term. So here's where you have an ability to apply some of our algebraic thinking to the method. Okay, there's a couple different ways that you can kind of look at this. The one I think at this point until there's complex ways to write the expressions out. Okay, I mean clearly I could take and say, well, for every side it is I could make this very long. Okay, and I could take and I could say, well, the bottom is, okay, now watch what I'm about to do here. 4x, right? That's the bottom, 4 times x. The top is 4 times x. You see that? So I've done the bottom, and I've done the top, check. This side here is, what is it? I already know the number. I'm just going to put it in. Well, even for that, I'm going to, let me make this 4 times x plus 4 times x. That side there is 4 times 3. I know there's an opposing side that's also 4 times 3. Plus, now this side here is 3x, right? This side. And then the side over here is also 3 times x. And what does it all equal? 80. Count my sides just real quick. 1, 2, 3, 4, 5, 6. I've got all 6 sides there. Now it's time, and this is what we were talking about earlier, is we got to get some like terms together, okay? So for just a moment, you can almost kind of come down through here and go, I know that's 12, 12. You see them? I can come down here and say, well, that's 24. You with me? How many total x's do I have? Well, 4, 8, 11. See them? 4, 8, 11, and then what's that? 14? And then what's it equal? 80. Now, I got to isolate x, okay? I'm going to isolate x. So in order to get rid of this 24, I want to subtract 24. That goes away. Whatever I do to one side, I have to do to the other side. Okay. Then I'm at a point where 80 minus, I'm going to regroup. 56 equals 14x. How many times will 14? Now, 14 times some number equals 56. So the opposite of multiplication is division. I'm going to divide that by 14. Then my x equals 4. Which, if you go back, what was x? Well, I changed my 3. See what I did? I swapped my 3 and 4, which wouldn't have mattered. But, x would, in this particular cube, x would have to equal 4 for that to equal 80 units, which is where you see the same numbers. You see a 4, and a 3 in that. But all I did was I created an equation with a missing value. I combined like terms. Then this looks messy right here. When I look at that, that looks messy, and it looks, but it's not. It's you taking each side and assigning an equation to it. You know that area equals length times width. I took every side. By unpacking it and making it a net, you can better understand that. But every side, 1, 2, 3, 4, 5, 6, is represented in my equation, and then it equals that number in which I'm given. And then I just combine like terms, and I got something much simpler. This here, once I simplified, it became simple, and then something you should be able to do. So that is where we are with our geometric nets. We've defined it. I've given you a few examples. I've showed you how to calculate surface area. And then, again, the missing information is me really just challenging you to think. I'm excited to see your work. If you have any issues, just let me know. But this should take care of you. And thank you for watching. Take it easy.